Welcome. Today we'll be going through question 3 from the New Zealand Maths Olympiad 2020. There are 13 mark points on the circumference of a circle with radius 13. Prove that we can choose 3 of the mark points which form a triangle with area less than 13. Please pause the video here and have a think about the problem on your own before proceeding to the hints and solutions. Hint number 1. So 13 is equal to 6 multiplied by 2 plus 1. Does this remind you of anything? Hint number 2. Try using the pigeonhole principle to simplify the problem. Now, if you are unaware of the pigeonhole principle, all it says is that if you want to put n plus 1 pigeons into n boxes, then at least one box will have at least 2 pigeons. In this problem, instead of boxes and pigeons, we have points and arcs. Hint number 3. So, using hint number 2, you may have found a certain arc where at least 3 points lie. Now find the triangle with the largest area on that arc and prove that that area is less than 13. Solution. So let us split the circle into 6 equal arcs as shown. Now 13 is equal to 6 multiplied by 2 plus 1. So by pigeonhole principle, there will be at least one arc on which at least 3 points lie. This is because in the worst case scenario, if we have 12 points, then there would be 2 points on each arc, but because we have 13 points, then the remaining point will have to go on one of the arcs, and that arc will then have 3 points. We will now find the triangle with the largest area on that arc and prove that that area is less than 13. So, because this arc is 1/6 of the circumference, angle AOB is 60 degrees. This means that triangle AOB is equilateral because AO and OB are both 13 and the angle between them is 60. Now let OC bisect AB. So C will be the midpoint of arc AB and D will be the midpoint of AB. Now, triangle ABC is the largest triangle that can be constructed in that arc. This is because it has the largest possible base, AB, and the largest possible height, CD. For example, this triangle has a base less than AB and a height less than CD. We will now show that the area of triangle ABC is less than 13. So first off, AD is half of 13, so 6.5, because D bisects AB. Now, using Pythagoras' theorem, the side OD has length square root of 169, 13 squared, minus 13 divided by 2 squared, which is 169 divided by 4, and that is equal to 13 multiplied by 1 minus a quarter, which is 3/4, and 13 multiplied by the square root of 3/4 is equal to 13 divided by 2 multiplied by the square root of 3. Now, side length DC is 13 OC minus side length OD, which is 13 divided by 2 multiplied by the square root of 3, and all of that is equal to 13 divided by 2 multiplied by 2 minus the square root of 3. So now we know the length of the base of triangle ABC and the length of the height of triangle ABC. So the area of ABC is half multiplied by base multiplied by height, which is half multiplied by 13 multiplied by 13 divided by 2 multiplied by 2 minus the square root of 3, which is 169 divided by 4 multiplied by 2 minus the square root of 3. Now, the square root of 3 is just greater than 1.7 because 1.7 squared is 2.89. So 2 minus the square root of 3 is just less than 0.3 because the larger the square root of 3 is, the smaller 2 minus the square root of 3 is. So 169 divided by 4 multiplied by 2 minus the square root of 3 is just less than 169 divided by 4 multiplied by 3/10, which is 0.3, which is the same as 12.675, which is less than 13. So we have proven that the area of triangle ABC is less than 13. Hence the area of any triangle in that arc must be less than 13, as we've previously discussed. Hence it is indeed possible to choose 3 points forming a triangle with area less than 13. Thank you for watching the video. Please like if you enjoyed it and feel free to drop a comment in the comments down below. Goodbye.